Alright, so we're going to work on the confidence interval for a difference of proportions. So since we went over some of the new formulas and things and conditions that have to be met for our difference of proportions yesterday's lesson, we're going to go through just an example here altogether, a problem, and work this out and show you how it's supposed to look and be finalized for 100%. Okay? So a recent random sample of 200 U.S. females revealed that 110 use Twitter regularly. A separate random sample of 150 males revealed that 60 use Twitter regularly. Construct a 90% confidence interval for the true difference of proportions who use Twitter regularly. Females minus males. So it's when you take the proportion of females minus the males. So in this case, we have two samples, right? We have a sample of females, it's 200. So we have our sample size 1, we'll call it 1 because females are in the front of this equation right here, females minus males. So we'll say that our N1 is 200. So we get 200 females. And that revealed 110 use Twitter regularly. So in this case, our p hat 1 is going to simply equal 110 over 200. And that's going to give us 0.55. All right, so now we're going to look at the second sample. Our second sample is 150 males. So for our second sample, our N2, at 150, and then it said that 60 of them use Twitter regularly. So for our P2 hat, all right, our second proportion here with a sample, we had 60 over 150. And that's going to give us 0.40 for the proportion of the second sample. All right, so now we at least have that set up. We got all that directly from our problem, as well as we have a 95% confidence interval. So again, we're going to want that to be 95%, okay? And that'll help determine our Z star value, which we'll get to that in a few minutes. That'll help us determine our Z star, okay? Start out with, though, let's look at the state part. So with this on our parameter, in which case, we're not just talking about our p-value, and we're not just talking about one sample. So the parameter is talking about, it's asking what it's talking about in the problem, in which case we're looking at females minus males. So in other words, what our P1 minus P2 is. So our P1 minus P2 is a true difference in proportions, okay? So that is the true difference in proportions for females minus males. True difference in proportions. And then you can just simply write females, right. Females minus males, okay? So that's your parameter. Your parameter is wanting to know what the p-value is talking about, or if you're dealing with means, what the mu is talking about. In this case, you're thinking of the difference, right? So we want to know what the difference of proportions is talking about. It's some of the true difference of proportions of females minus males. All right. Now, we already know our confidence level. We set that up there, right? This is going to be 95%, so we can simply write 95% right here. And our statistic. Well, our statistic, as we have simply said, are females, which we've labeled as P1, and our males as P2. So we can write out our P hat 1 minus our P hat 2, because the P hat is the actual statistic from the sample that you've taken. So in other words, this statistic of the females, the P hat 1, which we came to calculate is 0.55, minus the p hat 2, which we said was the proportion of males use Twitter, and that came out to be 0.4. So minus 0.4, and that equals 0.15. So our difference from p hat 1 minus p hat 2 is equal to 0.15. And that right there labels our state part. So now we can move on to the next part as dealing with our conditions. Okay. Now with our conditions as well, we also need to name the procedure. Right? So again, don't let this confuse you either. In the past, what we've been dealing with here in the past lessons, we've been dealing with one sample. And in this case, instead of proportions, it would deal with the z-test, right? Or in this case, they're dealing for intervals, right? We're trying to find out an interval, confidence interval. So that can be easily notated if you just think about what you're doing. Name of the procedure. We're doing a 2 sample, right? So we took 2 samples. We have females minus males. So 2 sample z. In this case, since we're looking for a confidence interval, we'll say z interval. And then 4, and in this case, just write out what it is. You're looking for P1 minus P2. All right, so that explains what the procedure is. A 2 sample, females minus males, Z interval, because we're doing proportions, or P1 minus P2. Now, conditions. Now, as we've been dealing with, we have 3 conditions, right? So first off, we can simply say, check off on the random part. Let's say we got random. Well, in the problem up here, they say random sample of females, random sample of 150 males. So we can simply note that. Just simply say a random sample of 200 females and a random sample of 150 males. All right, and that's good. You got random checked off. Boom. You got to list that out though. You can't just write random and check mark. You got to say how you know. Now, we can look at our 10% condition. So therefore, we can move forward with some calculations, right? So in this case, we would say we have to do this for both samples. We can't just do it for one, we have to do it for both. So our sample size is going to be less than 1/10 of the population, right? The overall. So for our females, we had 200, which is going to be less than 1/10 of all females. And then we had 150 males, so that's definitely going to be less than 1/10 of all males. I know it sounds kind of crazy to have to write that out and prove that that's the case, but you do. Statistics wants proof to back up all its calculations. So therefore, the 10% condition has to be met. All right. And now, let's look at dealing with, in this case, since we're dealing with proportions, to determine our approximately normal, we're going to use large counts. Because we're dealing with proportions, so large counts. Now you have to do this again for both samples. So we're simply going to take 200 times 0.55, because that's dealing with our females, right? Our females, sorry, jumping ahead here. So our females again had 0.55 right here. And our males had 0.4 for their p-values. So we're dealing with the females first. We have 200 times 0.55, which equals 1/10. then we have to take 200 times 1 minus p. So 1 minus p is 0.45, and that's going to equal 90. Then we do the males. So we have 150 times 0.4, which gives us 60. And we have 150 times 0.6, which is 1 minus p, or 1 minus 0.4, which is 0.6. And that gives us 90. And all four of these are greater than or equal to the value of 10. So if you write out like that and put a check mark, it's all good, because this tells us that we have an approximately normal curve. Not normal, approximately normal. Use that word approximately, because nothing is truly just normal. It's approximately normal. Okay? So that checks off all our conditions. So now we can move forward with actually doing the do part of this. So to look at these, we're simply going to do, I want to have you guys write out the general formula, specific formula, the work, and then the answer overall. Okay, so we can kind of understand how these work out and should play together. So the general formula, that is your point estimate, okay, plus or minus your margin of error, which has been the case for every type of confidence interval we've looked for. Take your point estimate plus or minus your margin of error. However, in this case, your point estimate just isn't from the one sample, it's from both, and it's the difference in this case. Your point estimate is your p hat 1 minus your p hat 2. Then we're going to take plus or minus margin of error. Well, your margin of error is going to be your z star times your standard error, which in this case is that somewhat kind of a long calculation for your standard deviation that we went over yesterday. So this is going to be z star times square root of both of those standard deviations added together. So you have to take, in this case, the p hat 1 times 1 minus your p hat 1 all over n1. And then you have to add your p hat 2 times 1 minus your p hat 2 all over your sample size, your second sample size. Then I recommend just plugging in the numbers and making this work, right? Well, we know what our p hat 1 minus p hat 2 is, because we set that up here. The initial setup, that was 0.15. All right. So we'll say 0.15. And in this case, we have plus or minus. And your z star, you should be able to do that. If you don't have it in memory, it's 1.96. But if you need to do the calculations, you can. Or you can simply look on the table there to determine what your z star is for 95% confidence, in which case you should get 1.96. Then we're going to take the square root and we're going to fill in all those numbers we had. Well, P1 again was 0.55, so take 0.55 times 1 minus that, which is 0.45, all over our sample size of 200 for the females. Plus, now we're going to worry about the males. The males had 0.4 times 1 minus p hat 2, which is 0.6, all divided by our sample size was 150 for the males. Okay, so let's see what that gives us. So you should get 0.15 plus or minus, and we do all this calculation here, you should come out to get around 0.15 0.104 is what I'm going to use. So with that, that's going to give us an interval of 0.046 for our lower, and our upper bound is going to be 0.254. And that's our confidence interval. We're 95% confident the 0.046 to 0.254 captures the true difference in Twitter usage between females and males. So let's talk about this and how we need to conclude this once we got this all written out for the calculations on the do part. So on this, to interpret, we are 95% confident that the interval from our lower bound, which is 0.046 to 0.254 captures the true difference in proportions of females and males who use Twitter. Or of females to males who use Twitter. Sorry, I misspoke there. So then you can simply say we estimate females use Twitter, let's put in percentage format, right? We'll say 4.6% to 25.4% more than males. All right. So we're saying that we're 95% confident the interval from 0.046 to 0.254 captures the true difference in proportions of females to males who use Twitter. In other words, that's saying we estimate females use Twitter 4.6% to 25.4% more than males. So females tend to use Twitter a little bit more than guys, according to the study that we did there. We're 95% confident that we should capture that data if we did more samples of that kind. All right, so let's look at an example from the book going over confidence intervals.
Hi, this is Jason Molesky. In this example, we'll construct a confidence interval for the difference of two population proportions. As a part of the Pew Internet and American Life project, researchers conducted two surveys in 2012. The first survey asked a random sample of 799 U.S. teens about their use of social media and the internet. A second survey posed a similar question to a random sample of 2,253 U.S. adults. In these two studies, 80% of teens and 69% of online adults use social networking sites. For this problem, we'll calculate the standard error of the sampling distribution of the difference in sample proportions. Then we want to know what information that value provides. Next, let's construct and interpret a 95% confidence interval for the difference between the proportion of all U.S. teens and adults who use social networking sites. Well, first let's calculate the standard error of the sampling distribution of that difference in sample proportions. The sample proportions of teens and adults who use social networking sites are p hat 1 equals 0.80 and p hat 2 equals 0.69 respectively. The standard error of the sampling distribution can be found using the formula square root p hat times 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p2 divided by n2. Inserting the values we were given in the appropriate places, we see that the standard error of the sampling distribution p hat 1 minus p hat 2 is 0.0172. What that means is if researchers repeated the random sampling process many times, the difference in sample proportions will typically be about 0.0172 from the actual difference in the population proportions. Next, let's construct and interpret a 95% confidence interval for the difference between the proportion of all U.S. teens and adults who use social networking sites. Well, we know that N1, the sample size, is 799, while p hat 1 is 0.80. Our second sample size was 2,253 for the adults, and the sampling proportion p hat 2 was 0.69. For a 95% confidence level, the critical value is z star equals 1.96. So our 95% confidence interval for P1 minus P2 is given by our confidence interval formula, where we have our estimate, the difference in our sample proportions, plus and minus a critical value times the standard error of the sampling distribution. So in this case, inserting the information we were given, our estimate will be 0.80 minus 0.69, plus and minus a critical value of 1.96, times our formula for the standard error. 0.11 is our observed difference, plus and minus 1.96 times that standard error that we calculated, and we receive an upper or a lower bound of 0.076 and an upper bound of 0.144 when we do the calculations. So to interpret that, we can say we are 95% confident that the interval from 0.076 to 0.144 captures the true difference in the proportion of all U.S. teens and adults who use social networking sites.
All right, so hopefully that example helped show you a little bit more about confidence intervals and going over what we just did in our example problem ourselves. So again, remember, state, plan, do, and conclude. And for the confidence intervals, on the state part, you need to talk about your parameter, confidence level, and statistic overall. For your plan, name the procedure, then check your conditions. Remember, random, 10%, and with proportions, it's large counts. Then with your do part, you don't technically need to do the general formula here. If anything, if you can write out the specific formula, or at least the work that goes along with the specific formula, that would be the best. All right, in which case, then you can actually calculate your interval by taking your point estimate plus or minus the margin of error that you do calculate based off of your Z star and your standard error. Then once you get that, then you need to write a conclusion. You need to write this out to prove you got your answer. So in this case, you're 95% confident, you're 90% confident, whatever percent confidence level they're telling you, that from the interval that you get captures the true, in this case, difference in proportions of the context, in which case the problem is talking about. And therefore you estimate that you do whatever the problem is referring to according to the percentage values you found for the interval and referring to the context in the problem. Okay? So remember, state, plan, do, and conclude. All right, so hopefully that helps clear a few things up. You learned a little something today, and I'll see you next time.